Today we will be taking a look at 2013 Aime I at number 4. So let's jump right into it.
In the array of 13 squares shown below, 8 squares are colored red, and the remaining 5 squares are colored blue. If one of all possible such colorings is chosen at random, the probability that the chosen colored array appears the same when rotated 90 degrees around the central square is 1 over n, where n is a positive integer. Find n.
In this problem, we have to shade 5 blue squares and 8 red squares in such a way that when we rotate the diagram 90 degrees about its central square over here, it remains essentially the same. It looks identical as before. And it's pretty simple. There's only a few ways to do this. Since we have to shade 5 blue squares, and we have like four of these outer 3 minnows, basically 3 minnows. Let's call them 3 minnows. The central square must be shaded because otherwise, if it's not shaded, there will be an imbalance of blue squares in each of these 3 minnows. So the central square must be shaded blue. That's a fact. Now, there are a few more ways to go about this. There's exactly 3 ways that we can shade the rest of the squares blue and having the configuration remain the same. We can shade all of these top outermost squares on the 3 minnows blue. That would give us 5 and an ideal configuration. We could also shade the central squares blue, or these inner ones, I guess, also blue. But the point being is that they all have to be shaded together. Like you have to shade all of the central squares, all of the outer squares, or all of the inner squares. You can't shade like a mixture of both. Otherwise, when it rotates, it will not be the same. So, for example, this is one possible configuration that would satisfy the problem's conditions. And this works like if you rotate it at 90 degrees either way about the central square, each 3 minnow is going to have these outer squares shaded blue, because it's just perfectly symmetrical. Like I said, it's also possible to shade these central squares and these outer squares. So in that case, it gives us we have 3 total configurations over all the number of possible combinations that don't necessarily satisfy the problem. There are a lot of these, but to count the total number of possible configurations, it's very simple. We have 13 squares that we can shade, and we're picking 5 to shade blue, so that essentially means the total amount of combinations is 13 choose 5. And this is because like the 5 shaded blue squares are indistinguishable, so that makes it a combination and not a permutation. So with that, we get that 3 over 13 choose 5 is 1 over 429, and the problem asked us for an answer in the form of 1 over n, so that gave us 429, which will be our final answer.